Ground fault circuit interrupter receptacles are recommended for a basement woodworking shop because they provide point-of-use protection and allow for easy resetting in the event of a false trip. When choosing ground fault circuit interrupter receptacles, consider Type GA or Type ground fault circuit interrupter receptacles. Type GA receptacles have a higher tolerance for motor loads, which helps in reducing false tripping. Type ground fault circuit interrupter receptacles are designed for frequent electronic load switching. It is critical to install the ground fault circuit interrupter receptacles correctly for them to function properly. This includes connecting the load and line wires to the appropriate terminals. Regularly test ground fault circuit interrupter receptacles using the test button to ensure they are functioning properly. It's important to consider issues that can cause false tripping. Motor loads can cause ground fault circuit interrupter receptacles to trip due to transient currents. To address this, use Type GA receptacles or consider using a separate circuit for motor-operated tools. Electronic tools with switching power supplies can generate high-frequency noise that can false trip ground fault circuit interrupter receptacles. To mitigate this, use Type ground fault circuit interrupter receptacles or install noise suppression filters on electronic devices. If the basement is prone to flooding, ground fault circuit interrupter receptacles should be installed at least 12 inches above the finished floor to minimize the risk of water damage. Ground fault circuit interrupter breakers provide whole circuit protection but are less convenient to reset than ground fault circuit interrupter receptacles. They may be suitable if there are multiple motor loads in the shop. The circuit supplying the receptacles should be protected by a circuit breaker or fuse of appropriate amperage. Also, consider installing surge protection devices to prevent damage to equipment from power surges. Using ground fault circuit interrupter receptacles is generally recommended in a basement woodworking shop. Type GA or Type ground fault circuit interrupter receptacles should be chosen to minimize false tripping. Proper installation, regular testing, and consideration of motor and electronic loads are essential for reliable protection. If water intrusion is a concern, ground fault circuit interrupter receptacles should be mounted high enough to avoid damage. Ensure all wiring complies with the National Electrical Code and local codes. If you are unfamiliar with electrical work, consult a qualified electrician. When installing ground fault circuit interrupter receptacles, be sure to de-energize the circuit at the breaker before beginning any work. Verify that the power is off using a non-contact voltage tester. Remove the existing receptacle and carefully disconnect the wires. Identify the line wires, which are the incoming power wires from the circuit breaker, and the load wires, which continue the circuit to other outlets or devices. Connect the line wires to the terminals marked line on the ground fault circuit interrupter receptacle. Connect the load wires to the terminals marked load. Ensure that all connections are secure and that no bare wires are exposed. Ground fault circuit interrupter receptacles have a grounding screw, which should be connected to the grounding wire in the electrical box. If the box is metal and properly grounded, the receptacle will also be grounded through the box. Carefully push the ground fault circuit interrupter receptacle into the electrical box, being careful not to pinch any wires. Secure the receptacle with screws and install the cover plate. After installing the ground fault circuit interrupter receptacle, test it to ensure that it is working properly. Press the test button on the receptacle. The receptacle should trip, indicating that the ground fault protection is functioning. Reset the receptacle by pressing the reset button. If the receptacle does not trip when the test button is pressed, there may be a wiring issue or a defective receptacle. Inspect the wiring and replace the receptacle if necessary. Regularly test the ground fault circuit interrupter receptacles in your woodworking shop to ensure that they are providing continuous protection. It is also a good idea to check the receptacles after any electrical storms or power surges. If you experience frequent false tripping of ground fault circuit interrupter receptacles, there are several steps you can take to troubleshoot the problem. Firstly, ensure that the receptacles are properly wired and that there are no loose connections. Secondly, check for any sources of electrical noise or interference that may be causing the receptacles to trip. This can include fluorescent lights, electronic ballasts, or other electrical equipment. Try moving these devices away from the ground fault circuit interrupter receptacles or installing noise filters on the devices. Thirdly, consider using a ground fault circuit interrupter receptacle with a high trip threshold. Some ground fault circuit interrupter receptacles are designed to be less sensitive to transient currents and may be less likely to false trip. If you are still experiencing problems with false tripping, consult a qualified electrician to diagnose and repair the issue. In addition to ground fault circuit interrupter protection, it is also important to consider other safety measures in your woodworking shop. Always wear appropriate safety gear, including eye protection, hearing protection, and a dust mask. Keep the shop clean and organized to prevent accidents. Use proper ventilation to remove dust and fumes. Store flammable materials in approved containers. And always disconnect power tools before performing maintenance or repairs. By following these safety precautions, you can create a safe and productive woodworking environment. When considering circuit protection for your woodworking shop, it's essential to understand the different types of breakers and fuses available and their respective amperage ratings. The amperage rating of a circuit breaker or fuse should be matched to the load of the circuit. Overloading a circuit can cause the breaker to trip or the fuse to blow, which can be inconvenient and potentially dangerous. To determine the appropriate amperage rating for a circuit, calculate the total load of all the devices that will be connected to the circuit. This can be done by adding up the wattage of each device and dividing by the voltage of the circuit, typically 120 volts in a residential setting. For example, if you have a circuit with a total load of 1500 watts, the amperage rating would be 1500 watts divided by 120 volts, which equals 12.5 amps. In this case, you would use a 15 amp breaker or fuse to protect the circuit. It is also important to consider the starting current of motor-operated tools. Motors can draw significantly more current when they start up than they do during normal operation. This starting current can cause a breaker to trip even if the circuit is not overloaded during normal operation. To address this, you may need to use a breaker or fuse with a higher amperage rating or a time delay breaker or fuse, which is designed to withstand temporary overloads. In addition to amperage rating, it is also important to consider the type of breaker or fuse. Circuit breakers are reusable devices that trip when a circuit is overloaded. They can be reset by simply flipping the switch back on. Fuses, on the other hand, are one-time devices that blow when a circuit is overloaded. They must be replaced after they blow. Circuit breakers are generally more convenient than fuses, but fuses can provide better protection against short circuits. There are also different types of circuit breakers, including standard breakers, ground fault circuit interrupter breakers, and arc fault circuit interrupter breakers. Ground fault circuit interrupter breakers provide protection against ground faults, which can occur when electricity leaks from a circuit to ground. Arc fault circuit interrupter breakers provide protection against arc faults, which can occur when there is a loose connection or damaged wire. It is important to choose the right type of breaker for the application. Ground fault circuit interrupter breakers are required in areas where there is a risk of water exposure, such as bathrooms and kitchens. Arc fault circuit interrupter breakers are required in bedrooms and other areas where there is a risk of fire. When installing circuit breakers or fuses, it is important to follow all applicable codes and regulations. The National Electrical Code provides detailed requirements for circuit protection. It is also important to consult with a qualified electrician if you are unsure about any aspect of circuit protection. Surge protection devices can help protect your electronic equipment from damage caused by power surges. Power surges are sudden increases in voltage that can occur due to lightning strikes, utility switching, or other events. These surges can damage sensitive electronic components such as computers, televisions, and appliances. Surge protection devices work by diverting excess voltage away from the protected equipment. They typically consist of a metal oxide varistor, which is a device that changes its resistance depending on the voltage applied to it. When the voltage is normal, the metal oxide varistor has a high resistance and does not conduct electricity. However, when a surge occurs, the metal oxide varistor's resistance drops dramatically, allowing the excess voltage to flow to ground. There are different types of surge protection devices available, including whole house surge protectors and point of view surge protectors. Whole house surge protectors are installed at the main electrical panel and provide protection for all of the circuits in the house. Point of view surge protectors are plugged into individual outlets and provide protection for specific devices. Whole house surge protectors are generally more effective than point of view surge protectors because they can protect against surges that originate outside of the house. However, point of view surge protectors can provide additional protection for sensitive electronic equipment. When choosing a surge protection device, it is important to consider the surge current rating. The surge current rating is the maximum amount of current that the device can withstand without failing. A higher surge current rating indicates better protection. It is also important to consider the voltage protection rating, which is the maximum voltage that the device will allow to pass through to the protected equipment. A low voltage protection rating indicates better protection. Surge protection devices should be installed according to the manufacturer's instructions. Whole house surge protectors should be installed by a qualified electrician. Point of view surge protectors can be easily installed by plugging them into an outlet. Surge protection devices should be tested regularly to ensure that they are working properly. Some surge protection devices have a built-in test function. Others require the use of a surge protector tester. Surge protection devices can degrade over time, so it is important to replace them periodically. The lifespan of a surge protection device depends on the frequency and severity of surges. However, most surge protection devices should be replaced every 2 to 3 years. In addition to surge protection devices, it is also important to have adequate grounding in your electrical system. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock and fire hazards. Grounding should be installed according to the National Electrical Code and local codes. It is also important to have your electrical system inspected regularly by a qualified electrician to ensure that it is safe and up to code. By taking these precautions, you can help protect your home and family from electrical hazards. When working with electricity, always follow these safety tips. Firstly, always turn off the power at the breaker before working on any electrical circuit. Secondly, use insulated tools to prevent electrical shock. Thirdly, never work on electrical circuits when you are wet or standing in water. Fourthly, always wear safety glasses to protect your eyes from sparks and debris. Fifthly, never overload electrical circuits. Sixthly, never run extension cords under rugs or furniture. Seventhly, never tamper with electrical equipment. Eighthly, if you are unsure about any aspect of electrical work, consult a qualified electrician. By following these safety tips, you can help prevent electrical accidents and injuries.